Hi, this is Lee from the Robby team. This is the first in what we plan to be a series of short videos exploring a software project I've been working on that we're calling the Robby Framework. If you've seen our Facebook posts at the We Are Robby account, you know I'm a software guy and have been pretty much my whole adult life. At this point, I've decided to take up robotics as a hobby. The picture on the screen is my first robot project, and I'm calling it Antwerp. This video is a high-level look at the Robby Framework. I'll be demonstrating how to use it to build a network that will communicate with an Arduino card and an Intel RS435i depth camera at the same time. In future videos, we'll dig deeper into the capabilities of the framework as I go through the process of marrying it to Antwerp. So, all that said, let's go ahead and jump over to the Robby Framework. This is what I call the main console of the UI. Before I said I was going to build a network to communicate with an Arduino and an Intel depth camera. So let's talk a little bit about what I meant by a network. So here in the main console, one of the things I can do, or the main thing I can do using the console, is load up an existing network to test, which we'll look at what it looks like to test in a little bit. The first thing to understand about networks is they're made up of channels. Channels transmit JSON messages between the main program on the master computer and the connected devices. You'll see that I call the program at the center the MCP, which stands for Master Control Program. Of course, anyone familiar with the movie Tron will know this as a shameless ripoff, but to be fair, I couldn't think of any name that's a better description of what it does, so I went with it. Probably the best way to explain channels will be to open the Channel Builder dialog. There's two main parts that make up a channel. Those are connectors and message schemas. Let's talk about message schemas first. All channels support two types of messages, from MCP messages and from device messages. In the channel, each message type is associated with a message schema, which defines the required format for that type of message. Connectors connect the channel to external devices or services used by the robot, as well as to the MCP itself. You can see the connectors I've built so far here in this list on the right. You can also see two special categories of connectors, image connectors and gadget connectors. Image connectors are connectors used for streaming video from camera sensors. Gadget connectors are Windows user controls that display either JSON message strings or streaming video. These gadgets will be displayed in the testing console, which we'll look at in a bit, and are also available as plugin libraries for specific implementation projects of the MCP. Now that you hopefully have some idea of what it is we're trying to accomplish, I'm going to go through the process of building and testing the simple network I described earlier. So we're going to close the Channel Builder dialog. The first step will be to build the message schemas we'll use for our channels. To do that, we'll go to the Message Schema Builder dialog, right here. We'll be using a total of 3 message schemas for our little demo network. I'm just going to build the simplest one here, and we'll use pre-built schemas for the other 2. So let's go ahead and build our message schema here. First, we're going to give it a name. We'll call it Demo Command Message Schema. And it's a message schema for commands. Simple enough. We're just going to give it 2 properties here. First, we're going to give it device ID, which will make us be a small integer. We'll say that has to be in the range of 1 to 25 and is a required property for the message. Then we're going to add one more. We're going to call this one device command, and it's going to be a string property with a maximum of 25 characters and will also be required. You can see these are reflected down here. Now I'm going to go ahead and save this off. And before we leave the message schema builder here, I'd like to talk a little bit about these 2 buttons here. the C++ button, and the C# button. The C# button generates a C# class file that matches the message schema. The class is created with a namespace you can set in configuration and saves it in a project folder also specified in the framework's config file. The C++ button does a very similar thing, except that it produces an Arduino compatible C++ header file set that includes functions to serialize and deserialize the C++ class it defines using the Arduino JSON library that you can get on GitHub for free. I'll show you how these header files can be used in an Arduino Sketch when we get to testing the network we're going to build. So now that we have our message schema built, we'll go back to the channel builder dialog to create a couple of channels for our network. The network we're building will have two channels, one for the Arduino and one for the Intel depth camera. Once again, we're just going to build one of the channels here and we'll reuse an existing channel for the other. The channel we're going to build will use a serial connector to communicate with the Arduino card and will simulate exchanging messages with it to control a servo. So let's go ahead and build our channel. First, we're going to give it a name. We'll call it Demo1 Servo Channel. And next, we're going to select the two message schemas for it. Remember, we need one message schema for from MCP messages coming through the channel and another one for the from device messages coming through the channel. So for the from MCP messages, we're going to use the schema that we built previously called Demo Command Message Schema. And for the from device messages, we're going to use a pre-existing schema here called Robot Arm Servo Message. So we've got our two message schemas. Now we're going to go ahead and start to add connectors. We're going to add first a serial connector, which will communicate with the Arduino card through the serial port on the computer. We're going to right-click it to configure it. First, all connectors must have a name. So I'm going to call this the Servo Device Connector. We're going to set it for a 9600 baud rate and to communicate on serial port number 3. Next, I'm going to put what we call a string connector on the other side of the channel to communicate with the MCP. The string connector is very simple. It does nothing but pass strings through from the MCP onto the other device connectors. So we're going to configure it. All it takes to configure it is a name. So we're going to call this one the Servo Command Connector. Now there's one more step to configure an MCP connector, and that is to set the device connector or connectors that you want it to send messages to. So in this case we only have one, so we're going to tell it to pass its messages through to the Servo Device Connector. Now we're going to add 3 instances of this string display gadget. The first one we're going to configure to talk to the MCP connector, the Servo Command Connector, and we're going to say that we want it to display MCP to device messages or from MCP messages. The next display gadget we're going to connect to the Servo Device Connector, so it's going to be on the device side, but we're still going to display the from MCP messages. So what we should see here is messages coming in from the MCP through the string connector being passed to the serial connector. Finally, on the third display gadget, we're going to set it up to also speak to the device connector, but it's going to display the device to MCP messages. In other words, when the Arduino card responds back to the commands that are sent to it with messages, we should see those in this display gadget as they're passed into the device connector. So that's what it takes to build our channel. We're going to go ahead and hit this button to save it and close the channel builder. There's one more very simple step required to complete our network, which is to specify which channels we want to include in it. This is done using the Network Builder dialog. There's just 2 steps here. First, we're going to give the network a name. We're going to call this the Demo1 Servo Network. Then we're simply going to drag the two channels that we want to include in the network from the list on the right. So you can see we have the Demo 1 servo channel that we created and the RS400 video demo channel, which will give us the stream from the Intel depth camera. So I'm just going to save this off, and now we have our network. But before we look at it in the testing console, I said earlier that I'd spend some time discussing how the C++ header files we can create in the message schema builder can be used in an Arduino Sketch. So let's open the Arduino IDE and take a quick look at the sketch we're going to use to test our network. You can see this is a dead simple little program. All it does is accept a serial message from the computer and use it to trigger a message that could be properties read from a servo. The properties will be populated with random integers. Notice that the name of the class we're instancing here in the sketch is robot arm servo message. Well, if you recall, in our channel that we built, the from device message schema was robot arm servo message. So this is that header file that I created using that button. Down here where we pass the message back, you can see I populate the properties on the object. Then I use this getJSON for message function to serialize the object and pass it back to the connector on the framework. Okay, we're finally ready for the fun part. We're going to test our little demo network. First, I'll load it into the main console here so it'll be ready for testing. There we go. Now I'm going to open the testing console dialog. Okay, let's expand it a little bit. On the testing console, each of the display gadgets included in the network's channels are automatically displayed. You can see the 3 string display gadgets as well as the very psychedelic depth camera image. That's always fun. But now let's take a look at how we can communicate with the Arduino card. Notice the 2 buttons at the top left. The one with the robot icon is for simulating messages coming from a device to a device connector. The one with the MCP icon is for simulating messages coming from the MCP to a from MCP connector on the channel. This is the one we're going to play with. In this dialog, I'm first going to select the channel I want to communicate with, which will be our Demo 1 servo channel. Then I'm going to indicate which connectors I want to send messages to. In this case, it's going to be the servo command connector, which is connected straight to the MCP. Next, I'm going to click this button here, which is going to bring up a dialog for building the JSON for the message. You can see that the structure of the message is reflected in the entry form. So I'm going to put some valid values in and click the Save and Close button. We'll say 12 and a random string of characters. Now I'm going to click the Save and Close button, and you can see here's my message ready to be sent on through to the testing console. So let's do that very thing. I'm going to click the Upload button, and you can see what happens here now. First, the message shows here being sent from my MCP simulator into the MCP connector, which sends it over to the device connector, which then passes it to the Arduino card, and after a slight delay you see the result come back from the Arduino card, which is that robot arm servo message populated with random integers. Now the thing to notice here also is that as I'm doing this, there's no interruption to the video display. This is all independently threaded within the framework. So that's our introduction to the Robby framework. We really appreciate you taking the time to check it out. As I said earlier, in future videos we'll dig deeper into how I'll use the framework to control my robot project named Antwerp. That's all for now, and thanks one more time for watching.